Have you ever stood on a beach at low tide, looked down at that vast, wet, mirror-like expanse of sand stretching to the horizon, and felt a sudden, profound shift in your perspective? That moment, right there, is not just a pretty scene. It is one of the most profound and deceptive portals on our planet, a temporary universe laid bare. And what you are seeing is a complex, living, breathing entity that holds secrets about everything from cosmic geometry and ancient cataclysms to the very future of life on Earth. This is not merely sand and water. This is a liquid mirror reflecting the history of our world, a canvas painted by the moon's gravity, and a battlefield for survival played out on a microscopic scale. I want you to come with me on a journey into that reflective surface, to peer beyond the simple beauty and into a realm of astonishing complexity. Forget everything you think you know about a calm beach. That serene, shiny surface is a lie, a beautiful, reflective lie. Beneath your feet, in that thin film of salt water, an entire civilization is thriving, communicating, hunting, and hiding. The sand itself is a library, each grain a book, with a story millions of years in the making. The reflections of clouds and sky are dancing over a landscape more intricate and alien than any rainforest canopy. Today, we are going to decode that landscape. We are going to explore the physics that makes it a perfect mirror, the biology that teems within it, the geology that constructed it, and the existential lessons it whispers to us if we're quiet enough to listen. This is a narrative of interconnectedness, written in water, sand, and light, and it begins with a single fundamental question. What are you actually looking at when you see that glossy, wet sand? The answer begins with light itself, and how this most ordinary of materials becomes, for a few hours, one of nature's most perfect optical instruments. When the tide recedes, it leaves behind sediment that is saturated, where the spaces between the sand grains are completely filled with water. This is the critical transition. Dry sand is a chaotic scatter of light. Photons hit the rough, multifaceted surfaces of quartz and other minerals and bounce off in a million different directions, which is why dry sand appears matte and bright. But when a thin, continuous film of water coats those grains, it fills in all the microscopic voids and creates a much smoother top layer. Now, light isn't hitting a rough surface. It's hitting what is essentially a liquid plane. A significant portion of light rays now obey the law of reflection. The angle of incidence equals the angle of reflection, just like they would on a polished piece of glass or a still lake. This creates specular reflection, the mirror-like effect that shows you the sky. But it's not a perfect mirror like glass. It's a damp, granular mirror. The remaining light penetrates this thin film, scatters through the water-coated grains beneath in a process called subsurface scattering, and reemerges with a deep, saturated color, giving the sand that rich, dark, earthy tone. This interplay between the reflected sky and the inherent color of the damp sediment is what creates that breathtaking, almost ethereal contrast. But the magic of this mirror is its temporary, fragile nature. It exists in a perfect equilibrium between the land and the sea, a balance dictated by the gravitational pull of a celestial body over 384,000 kilometers away. The moon's tug creates the tidal bulge that ebbs and flows, and as the water table within the beach drains to match the falling ocean level, it leaves just the right amount of moisture behind, not too much to be a puddle, not too little to be dry. It is a planetary scale phenomenon, resulting in a hyper-localized work of art. And as you stand there, your feet disrupting this perfect surface, your footprints become more than just impressions. They are temporary disruptions in this optical field, wells where water pools and alters the reflective geometry, creating dark trails that chart your passage through this mirrored world. They are a reminder of your intrusion into a system that operates on scales both vast and minute. And while you're contemplating your footprint, consider this: the very sand you're standing on is likely not from here. It is a traveler, a migrant, That grain of quartz might have begun its life as part of a massive granite mountain range inland, slowly eroded by wind and rain, carried grain by rivers over millennia, tumbled and smoothed in the process, only to be deposited here, at the coast, where waves and currents took over its sculpting. Its journey is an epic saga of planetary transformation. And amongst the quartz, you'll find other citizens of this granular library: black magnetite from volcanic eruptions, pink garnet from high-grade metamorphic rocks, tiny fragments of shell and coral that speak of ancient reefs. This wet mirror is thus a historical archive, showing you not the sky of today, but the geology of eons past, reflected in a shimmering, present moment tableau. But the story gets even more profound when we realize this environment is not barren. It is one of the most productive and harsh ecosystems on Earth, known as the intertidal zone. And the fact that it is exposed, that this wet sand world is revealed, is the central drama for millions of organisms whose entire existence is a cycle of submersion and exposure, of breathing war and breathing air, of feast and famine tied to the lunar clock. So we have this reflective surface, this temporary mirror created by physics and celestial mechanics. But now let's shatter that mirror metaphorically and look at what it's hiding. Because that smooth, glossy plane is a roof. It's the ceiling of a bustling, frantic, and often violent metropolis that exists entirely in the dark, in the damp, under a few millimeters of saturated sand. This is the world of the interstitial, the space between. And for the organisms that live here, the exposure at low tide is their apocalypse, their drought, their daily crisis. They don't see the beauty of the reflections. They experience the terror of the receding sea. The primary challenge is desiccation, drying out. So they burrow. The wet sand is their refuge. As the water drains away, it leaves behind moisture in the tiny spaces between grains, and life here has evolved to exploit those microscopic films of water. Take the humble lugworm. You see its coiled castings on the surface, little piles of processed sand that are the equivalent of skyscraper exhaust vents. Below, the lugworm is in its U-shaped burrow, constantly ingesting sand to digest the microalgae and detritus coating the grains, and breathing through its gills in the trapped seawater. Its world is the size of its tunnel, and low tide is a time of quiet waiting. Then there are the bivalves, the clams and cockles. They have powerful muscular feet that can plunge them deep into the sediment as the tide falls. Some, like the razor clam, can dig with astonishing speed, using a complex biomechanical process that fluidizes the sand around its shell, allowing it to sink as if into quicksand. Once buried, they shut their shells tightly, trapping a reservoir of cool, salty water inside, a personal ocean to keep their gills moist until the sea returns. But the real masters of this hidden world are the crustaceans. The ghost crab, which often ventures onto the dry sand, has a different strategy. It retreats to a deep, often waterline burrow above the high tide line, plugging the entrance to maintain humidity. But down in the wet sand itself, consider the mole crab or sand flea. It is a living filter feeder that follows the tide, burrowing into the swash zone where waves wash up, then emerging to catch plankton with its antennae as each new wave surges for it. Low tide is a shutdown of operations. It simply buries itself and waits. And then there are the microscopic architects, the diatoms. These single-celled algae are the secret source of the intertidal zone's productivity. Millions of them live on and between the sand grains, photosynthesizing when the tide is out and the sun is shining directly on the exposed flat. They secrete natural oils and mucilage which actually help bind the sand grains together, stabilizing the sediment. They are the prairie grasses of this granular savanna, the base of a food web that supports everything from tiny worms to shorebirds. But life here isn't just about hiding, it's also about hunting. The low tide exposure is a dinner bell for aerial and terrestrial predators. This is when the shorebirds arrive in force. The sandpiper, with its sensitive bill that can feel the vibrations of a worm buried inches below the surface, probes the wet sand with metronomic precision. The oyster catcher uses its bright orange blade-like bill to pry open bivalves or snatch worms. Your presence, your footprints, are sending shock waves through this hidden city, alerting prey to danger, collapsing tiny burrows, altering the landscape. That beautiful, reflective surface is, for them, a fragile shield against a world of threats from above. And the wetness of the sand is critical to all this life. It provides structural stability. For burrows, dry sand collapses, but water-cohesive sand holds tunnels. It mediates temperature, preventing the extreme heat that bakes the dry upper beach. It allows for the diffusion of gases. Oxygen can still seep down through the water film to buried creatures, and they can excrete waste. This hidden metropolis runs on the physics of poor water. But there's another, even more mysterious layer to this. The wet, reflective sand is also a recording device and natural tablet. It records the passage of every creature that moves across or within it. The trails of a snail become miniature canyons. The symmetrical star pattern of a burrowing sea urchin spine marks the delicate, stitch-like tracks of a beach hopper. These are the streets and highways of the hidden city etched in real time, and they are ephemeral, destined to be wiped clean by the next high tide, a daily renewal of the canvas. This cycle of revelation and erasure, of exposure and concealment, is the fundamental rhythm of life here. It demands incredible resilience and flexibility. Organisms here have biological clocks synced not to the sun, but to the moon and tides. Their metabolism, feeding, reproduction all are timed to this aquatic pulse. When you look at that reflective sand, you are looking at the closed lid of a biological pressure cooker, a habitat of extreme stress that fosters unbelievable innovation and survival. From the worm that rebuilds its home every day to the clam that can survive for weeks without food or fresh oxygenated water, these are some of the toughest organisms on the planet, living in a world that literally disappears from under them twice a day. And this brings us to the sand itself, because this entire hidden metropolis is built upon a foundation that is in itself a narrative of destruction, journey, and transformation. The mirror is made of shattered mountains. Let's take a single grain of sand from that wet, reflective expanse. Hold it in your imagination. It is tiny, almost insignificant. But its story is the story of continents in motion. Most beach sand is dominated by quartz, silicon dioxide. And quartz is a survivor. It begins its life deep within the Earth's crust as a crystalline component of igneous rocks like granite. Through the immense, slow forces of tectonics, that granite mountain is pushed up. Then, the agents of destruction begin wind, rain, ice, and chemical weathering. They attack the granite, breaking apart the weaker feldspar and mica minerals, liberating the harder, more resistant quartz crystals. This is the first winnowing. The quartz, now a grain of sand, is carried by streams and rivers. This journey is a brutal tumbler, as it bounces along riverbeds for hundreds, maybe thousands of miles. It collides with other grains. Its sharp, angular edges are slowly worn down, becoming rounded and smooth. This rounding is a signature of its travel history. A perfectly round grain has seen a long, turbulent journey. The river eventually deposits it into the ocean's delta, but its journey is far from over. Now ocean currents and waves take over. Longshore currents, moving parallel to the coast, act as colossal conveyor belts, transporting the sand along the shoreline. Waves, especially during storms, are the master sculptors. They lift sand from the seabed and, depending on their power, sort it by size and density. The wet, reflective low tide zone is often composed of these well-sorted, fine to medium sands. The grains are similar in size because the wave energy here has placed them just so. Heavier minerals like magnetite, which gives sand its black streaks, or garnet, often settle out in different patterns, creating layers. This is why you sometimes see ribbons of dark sand in the wet mirror. It's a density sorting on a grand scale. But not all sand is quartz. On tropical shores, the sand is often white and made primarily of calcium carbonate, the ground-up remains of living things. Corals, shells, foraminifera, the skeletons of marine algae. Here, the reflective wet sand is a mirror made of death, or more precisely, made of recycled life. Every grain was once part of an organism that extracted minerals from the sea to build its architecture. When that organism died, its structure was broken down by waves and boring creatures, eventually becoming the fine, powdery sand that reflects the palm trees and blue sky so perfectly. This sand is local, born of the nearby reef, not transported from distant mountains. Its journey is a biological cycle, not a geological one. And then there are the exotic sands, the green sands of Olivine and Hawaii, the black volcanic sands of Iceland, the pink sands of Bermuda tinged with broken coral and shell. Each beach's wet mirror is thus composed of a unique blend of these histories. The reflectivity, interestingly, is influenced by this composition. Quartz and calcium carbonate have different refractive indices, meaning they interact with light in subtly different ways when wet. A quartz-based wet sand might have a cooler, grayer reflection, while a carbonate sand can have a warmer, brighter glow. But the story gets even more cosmic. Some of the grains in that sand might be extraterrestrial. Microscopic spherules of iron-nickel or strange silicate minerals can be found, the dust from distant asteroids or comets that has settled through the Earth's atmosphere and found its way into the sedimentary cycle. So in that wet sand, you are potentially standing on stardust, on the remains of ancient mountains, and on the rubble of coral castles, all mixed together and polished by the planetary engine of water and wind. This mixture is not static. The low tide zone is a dynamic factory. The action of waves, even small ones, on this saturated sand can create fascinating structures. You might see ripple marks, small, parallel ridges on the surface. These are not frozen waves. They are the instantaneous fingerprint of the last water movement over the sand. The size and spacing of the ripples tell a physicist the velocity of the water and the size of the sand grains. They are a logbook of recent energy expenditure. Sometimes you see bubbling holes. That's the trapped air from the receding tide being forced out by water draining downward the breadth of the beach itself. And on occasion you can find quicksand. That's essentially what this whole zone is when it's saturated, a fluidized bed. If you disturb it vigorously, you increase the pore water pressure, the grains lose their friction, and you sink. It's a demonstration of the precarious liquid-solid duality of this environment. The sand is solid enough to walk on, yet liquid enough to swallow a clam or allow a worm to swim through it. This entire geological and physical saga, the mountain's erosion, the river's transport, the ocean's sorting, the waves' patterning culminates in this perfect, reflective sheet at low tide. It is the temporary, peaceful face of a process that is fundamentally violent and enormously powerful. It represents a moment of balance in a system of constant flux. And this balance, this very exposure of the seabed, has been a catalyst for one of the most significant evolutionary leaps in the history of our planet. Because long ago, this exact environment, the shallow, tidal, sun-drenched margins of continents, is where life is believed to have made its bold, terrifying move from the sea onto the land. The wet, reflective sand of the Silurian or Devonian period was the testing ground for the first arthropods and early vertebrates. Experimenting with breathing air, resisting desiccation, and supporting their bodies without water's buoyancy. Every low tide was an opportunity, a challenge, and a danger. That mirror, therefore, is not just a record of the past. It is a stage upon which the future of life was rehearsed. We've looked down at the hidden biology and back at the deep geological history. Now let's look outwards. That expansive, wet, reflective surface is more than a habitat or a geological record. It is a psychological and philosophical mirror for us. There's a reason humans are drawn to this liminal space, this edge of the world. The reflective quality literally doubles the landscape, merging sky and earth, creating a sense of infinite space and profound emptiness. This can trigger a powerful psychological response, a feeling of awe. Awe is that emotion we feel in the presence of something vast that transcends our understanding, and it has measurable effects. It can reduce stress, increase feelings of connectedness, and make us more curious and open-minded. The low tide flat, especially a vast one, induces awe through its sheer scale and simplicity. The horizon is distant, the sky is huge, and the world is reduced to elemental components: water, sand, air, and light. In our cluttered, noisy lives, this minimalist vista provides a cognitive reset. The mirror effect itself is meditative. It forces a different kind of perception. You find yourself looking down to see the sky, blending the heavens and the earth in a way that disrupts normal orientation. This can induce a mild, peaceful state of dissociation, a quieting of the internal narrative as the brain tries to process this inverted world. It's a natural form of mindfulness. You are compelled to be present, to watch your step, to observe the details in the reflection. Furthermore, this environment is a masterclass in impermanence. You are witnessing a scene that will be utterly gone in a few hours. The mirror will be shattered by the advancing waves. The hidden city will be submerged. The recorded tracks will be erased. This daily cycle of creation and destruction is a powerful, nonverbal lesson in letting go, in the transient nature of all things, a concept central to many philosophical and spiritual traditions. The Japanese aesthetic of wabi-sabi, which finds beauty in imperfection and transience, is perfectly embodied in the low tide flat. The mirror is never flawless. It has bumps from worm casts, cracks from drying, footprints, and debris. It is beautiful precisely because it is temporary and imperfect. For artists and poets, it has been a constant muse. The way it transforms the familiar into the dreamlike, the way it merges realities, speaks to the creative process itself, the blending of inspiration, the sky, with the earthly medium, the sand. But beyond the personal and artistic, this wet sand zone holds critical, urgent lessons for our global future. It is a barometer for planetary health. Beaches are dynamic. They erode and accrete in natural cycles, but the low tide zone is where changes in sea level and storm intensity become dramatically visible. A rising sea level will change the fundamental dynamics of this zone, potentially drowning it permanently or shifting it inland. Changes in wave energy from more frequent storms can alter the grain size distribution, destroying the delicate balance needed for that perfect reflectivity and, more importantly, for the hidden ecosystem. The organisms here are adapted to a specific range of conditions. Rapid change can outpace their ability to adapt. Furthermore, this reflective surface is vulnerable to our pollution. A sheen of oil would destroy the reflectivity by changing the surface tension of the water film, creating a matte, deadly coating that would also suffocate the interstitial life. Microplastics are now found integrated into beach sand worldwide. These tiny particles, often the same size as sand grains, infiltrate the habitat, are ingested by filter feeders, and enter the food web. When you look at that pristine-looking mirror, it is increasingly likely that it is laced with this invisible, human-made contamination. The wet sand flat is also a crucial carbon processor. The microalgae diatoms photosynthesize, pulling carbon dioxide from the air. Organic matter gets buried in the sediment. In this way, healthy coastal ecosystems are modest carbon sinks. Degrading them has a small but real climate impact. So, this serene place is on the front line of the climate and biodiversity crisis. Its existence is a sign of a still functioning coastal process. Its degradation is an early warning sign. This connects to a broader scientific principle visible here: emergent complexity. Simple rules: the pull of gravity, the properties of silicon and water, the principles of natural selection give rise, through endless iterations and interactions, to the breathtakingly complex scene before you, the perfect optical mirror, the intricate burrow systems, the synchronized behaviors, the geological diversity. Simple laws beauty and complexity emerge. This is a fundamental pattern in the universe. From the formation of galaxies to the growth of a snowflake to the organization of an economy, the low tide flat is a slow motion, accessible demonstration of this universal principle. It shows how stability arises from constant change, how life thrives in disequilibrium, and how profound beauty can be a side effect of brutal physical processes. When you stand there, you are not just at the edge of the ocean, you are at the intersection of physics, biology, geology, psychology, and philosophy. The wet sand is a lens that focuses these disparate fields into a single, coherent, and deeply moving experience. It asks us to consider our place not as separate observers, but as participants in this system. Your footprint is part of the record today. Your actions, as a member of a global society, will impact whether this phenomenon persists for future generations to experience and learn from. This leads us to the final and perhaps most humbling perspective to see this shoreline not as a place on Earth, but as a template for worlds beyond our own. Now let's take the ultimate leap of perspective. Let's imagine we are not on Earth. The next time you see that vast, wet, reflective plain at low tide, I want you to consider that you might be looking at a scene that is universal. Astronomers and astrobiologists now believe that liquid water is likely common beneath the surfaces of icy moons in our outer solar system. Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, are the prime candidates. Both have solid, icy crusts. But beneath that ice, strong evidence suggests they have global, salty oceans more voluminous than Earth's, kept liquid by tidal forces, the same gravitational tug-of-war that creates our tides, but acting on a moon's interior. Now imagine if that ice shell on Europa is thin in places, or has cracks. Imagine a scenario where the subsurface ocean, under pressure, wells up into these cracks and then recedes, much like a tide. Could there be, on the floor of that subsurface ocean, or perhaps even in the slushy ice itself, a layer of granular material, not sand, but perhaps sintered ice particles or rocky sediment from the moon's core that becomes saturated with this salty water? Could there be a moment of exposure, or near exposure, where a wet, grainy surface is created? It wouldn't reflect a blue sky, but it might reflect the dim glow from Jupiter's scattered light, or the shimmer of bioluminescence from unknown organisms. The point is, the physical principles are the same. A granular material, a liquid, and a phase change between exposure and submersion. This means the intertidal zone we are exploring today is the closest analog we have on Earth to what might be the most promising habitat for extraterrestrial life in our solar system. The organisms in our wet sand, the ones that survive without sunlight, in cold, dark, high pressure, salty conditions, living on chemical energy from hydrothermal vents or from the breakdown of minerals, are the models for what we might find out there. Extremophiles called chemolithotrophs, which get energy from rocks and chemicals, already live in Earth's deep sea vents and within porous rocks. The transition zone between ice and water on another world would be a place of intense chemical and thermal gradients, a paradise for such life if it exists. So, studying how life survives and thrives in the harsh, cyclic, hidden world of our own tidal flats directly informs the search for life beyond Earth. Your local beach is a training ground for astrobiology, but let's bring it back home to the final, tangible lesson of the reflective sand. It teaches us about attention and scale. To appreciate it, you must slow down. You must look down. You must get close. The grand, awe-inspiring vista is beautiful, but the true magic is in the details, in the single, perfect reflection of a cloud in a footprints puddle, in the intricate pattern of a tiny shell pressed into the mirror, in the trail of a worm that looks like a miniature river delta from above. This shift in scale from the planetary, tides, moon, to the personal, your footprint, to the microscopic, the diatom, is an exercise in cognitive flexibility. It is the antidote to a world that often forces us to look at only one scale, our immediate human-sized concerns. The wet sand flat forces you to simultaneously contemplate the cosmic of the minute, and this brings us, inevitably, to our role. This environment is resilient but fragile. It has survived ice ages and asteroid impacts, but it may not survive the cumulative, localized pressures of human activity, coastal development, pollution, reckless recreation, and the overarching threat of climate change. What can you do? The first and simplest thing is to observe and appreciate. Understand what you are looking at. Share that knowledge. When you walk on a tidal flat, be mindful. Walk gently. Avoid stepping on dense clusters of shellfish or obvious life. If you turn over a rock to look at crabs, put it back exactly as you found it. It's a roof for many creatures. Take your trash and any you see with you. Support local and global conservation efforts aimed at protecting coastal ecosystems. Advocate for policies that address climate change and reduce plastic pollution. On a deeper level, let the lessons of this place seep into your worldview. Embrace impermanence, seek out awe. Look for the hidden complexities in seemingly simple things. Find the interconnectedness, the thread that links the moon and the sky, to the wetness of the sand, to the burrowing clam, to the migrating bird, to the chemistry of the ocean, and to your own sense of wonder. That reflective surface is a call to curiosity, a demand for a deeper inquiry into the natural world. So, the next time you have the chance, go to a beach at low tide. Go alone or with someone willing to be quiet. Walk out onto that wet, shining plain. Look down at your feet. See the sky below you. Breathe the salty air. Know that you are standing on a mountain's remains above a hidden city, beside an alien laboratory, at the edge of a planetary heartbeat. You are participating in a cycle as old as the Earth-Moon system. You are witnessing a daily miracle of physics, a masterpiece of biology, and a living lesson in time and change. That mirror is not just showing you the sky. It is offering you a reflection of a universe built on connections, cycles, and breathtaking ingenuity. It is showing you that the boundary between the ordinary and the extraordinary is as thin as a film of water on sand. This is why that simple sight of shoreline at low tide revealing wet reflective sand is perhaps one of the most important vistas on our planet. It is a classroom, a laboratory, a sanctuary, and a warning. I urge you, don't let it be just a background for a holiday photo. Seek it out, study it, protect it, and most importantly, share this perspective. Tell someone what you now know. Take a child and show them the hidden world in a bucket of sand. Your awareness and your voice are part of the ecosystem now. If this journey across 5,000 words and 5 perspectives has changed how you see that reflective strip between land and sea, then my purpose is complete. Now it's your turn. Go out, find your low tide, and start looking down. The universe is waiting right beneath your feet.